Fine. Okay, so you have done reading the 5.1, right?
Mm.
Okay, so what is the difference between combustion and burning?
Burn is burn is fire. Burn got fire and combustion.
Yes, combustion might not have fire, right? But it will have the oxygen. Yes, you are right. Okay, and then there is a change of the energy. It changed from what kind of energy to what kind of energy? Burning. It changed from, you see, fuel. We burn fuel because fuel has energy, right? So it changed from what energy to what energy?
Fuel energy to heat energy.
Okay, where can you find the fuel?
Inside the
Conversion of energy. You can see my PowerPoint, right? So
yes.
the chemical energy, it is chemical energy converted into the heat energy plus light energy. Sometimes you can hear the sound. So, and the sound energy. So where does the chemical energy comes from? It is from the fuel. F-U-E-L. Right?
Yes.
So you know this one and you know combustion. Before this, we all know only burning. Now it is combustion. Combustion is a fast one. So for example, in your book there, right? Carbon plus oxygen, it will form what?
Carbon dioxide.
Yes, okay. So this is actually energy is giving out, right? Whenever energy is giving out, we call this exothermic reaction. So far, so good.
Okay.
All right. Now, let us go to page 71. You have read through also, right?
Yes.
Okay.
But
So you see,
really,
oh, you don't understand, Is it?
yeah.
Okay. Wait, let me see. Number 1 is 2. Okay. So, combustion of hydrogen and water. Where is it right here? Okay, on your textbook 71, hydrogen plus oxygen, it makes water, right?
Yes.
So hydrogen plus oxygen, because oxygen is needed in order for combustion to happen, it makes water and it also releases energy. So this type of reaction is known as what? What is the reaction? It releases energy. Exothermic reaction. Whenever you see the word like thermic or thermal or term something, you know already it has something to do with the heat. Okay, exothermic, heat energy is acid, heat energy is giving out, right? And then likewise, another example, burning of magnesium oxide, right? Hello?
Yes.
Burning of magnesium oxide. When you touch the magnesium oxide, when they just form, is it hot?
Yes.
Why is it hot?
Because it releases the heat energy.
Yes, it releases heat energy. Again, this is exothermic reaction. All right. Now, oxidation. You learn about the combustion, right? So what is oxidation?
react with oxygen.
Yes, oxidation means the reaction with oxygen. It might not have fire. For example, the rusting one. Do I have this one? Oh, okay. For example, the rust. You know, like the process of forming rust. Oh, okay. You see. What about making? Okay. So you see, oh, I'm talking about the rust, right? So rust, it is like the reddish brown color thing, right? How does it form? Rusting process. How does it form? How does it become rust?
Something metal react with oxygen
Yes,
and hydrogen.
and water. In order to rust, you need to have oxygen and water, right? So what does that mean? If there is no oxygen, no water, then rust will not form, right?
Yes.
So you see, although although the rusting, right, it does not have fire, but it is an oxidation reaction. Example of oxidation. Understand? It is very slow, right? It takes like a few days or a few months to form a rust, right?
Yes.
So this rusting is an oxidation, but it is a slow reaction. Okay.
Okay.
So now I'm going to tell you more about the thermochemistry. Okay, so there are two types of the reaction, as you can see here. Can you read them out for me?
Exothermic reaction, a reaction in which heat energy will be given out during the process. Endothermic reaction, and a reaction in which heat energy is being absorbed from the surrounding and stored in the form of chemical energy.
Now, can you please go to your first page here? This one, the first two column here, is for you to write down the definition. Can you write out the definition now? Please write out the definition now. This note, right, is actually very, very useful. It covers everything from Unit 5 to Unit 7. So you see, I summarized it into like just 6 pages.
Teacher, may I go to the toilet?
You let me know when you are back.
Okay. Okay, I'm back.
Okay. Yeah, you have done copying, right?
Yes.
Okay. Heat energy is heat energy out. This one means out. This one means absorb. Heat energy absorb. So, okay, can you tell me why the heat energy is released, the temperature increases? Why when the heat energy is released, is coming out, release, then the temperature will increase? Why? Why is that so? Because heat energy is releasing, right?
Because the energy is,
You can imagine like you are cooking. When you're cooking, right, when you touch the pot, it is hot. Why? The hot is coming from the fire, right? Heat energy is giving out. So when energy is giving out, it is spread to whatever item, the item will be hot, right? So temperature increases. So far, so good.
yes.
Okay. You can also make notes about this. Temperature increases and temperature decreases. So you are done with this one, right?
Yes.
Okay. Now let us continue to look at the next one. I want to show you. Okay, so this one you know already, right? Exo and undo. Okay, so what is the example of exothermic? Can you tell me any of them? Example. Sorry?
Rusting.
I can hear you.
Rusting.
What is lasting?
Rusting.
Or rusting, okay, yes. So although when it is rust, when you touch the surface, it is not hot. Why? Because only little energy is released, also because it is low. So we might not be there to touch when the rusting is taking place. What else? What else is exothermic?
Neutralization.
So yes, you know what is neutralization, right? What is neutralization? Yes, what is neutralization?
Middle the thing.
Yes, to make the solution neutral, right? So neutralization, it is actually acid plus alkali, right? Alkali, right?
Yes.
It will form pH 7 neutral solution, right? It will form salt and water neutralization, right? So you see, when you first plus the very, very strong acid, hydrochloric acid, and the very, very strong alkali, sodium hydroxide, you add two of them together in a beaker, you stir, 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 you use your hand to touch the beaker, right? You will feel, oh my God, it's very hot, or it is slightly warmer. Why? Because heat energy is released. So neutralization is an example of exothermic reaction. So far, so good.
Yes.
Okay, and just now we learned about metal plus oxygen, metal plus water, metal plus acid. All of this, it is actually what? Exothermic reaction.
So all the reaction of metal is exothermic reaction.
Actually, there are a lot of other reactions with metal, but this is only like a few of them. So the basics one, like all of these, oxygen, water, and acid, they are all exothermic. Okay, even the displacement just now, is the displacement, does it release heat energy?
Yes.
Yes, right. So it is also exothermic. Think about what is that one? Aluminium and iron oxide, right? Aluminium welding, right? Welding. They use aluminium and iron oxide displacement, because why? Whatever reaction that releases heat energy is the exothermic. So far so good?
Yes.
Okay, so now let us look at more example. You know the exothermic already, right? So what is the other example of exothermic in our daily life? It is the making the ice cube. So you might feel that, doesn't that temperature will need to increase? But you see, making the ice cube, they need to release the energy. Only then they can become cold, right? So making ice cube or freezing is actually exothermic reaction. So far, so good.
Yes.
Okay, so now I'm going to focus on undo. Undo means what? Heat energy is absorbed, right? Heat energy absorbed. So you see, when you are cooking an egg, do you need energy?
Yes.
Because the egg need to absorb energy, endothermic. When you photosynthesis is also an endothermic, because why? The plant, they absorb sunlight, right? Absorb sunlight. So that one is also sunlight. It is the source of heat energy. So endothermic reaction. Okay. How about evaporation? The water, when they absorb the heat energy, they become full of energy. So they can turn into water vapor. Okay. So far, so good.
Yes.
Okay. Now, I would like you to complete the examples here. What are the examples I should have written here? Which one is which one? Yes. Okay. Write your answer there. You can write anything. If you want to write more than 4, that is totally fine. Neutralization. Reaction between metal and oxygen. Reaction between metal and water. Reaction between metal and acid. A lot. Between metal, carbonate, and acid. A lot, right? What else? Oh, combustion. Okay, so what is the example of the endothermic reaction?
Melting ice cube.
Melting, very good, melting. How about evaporation? Evaporation. Dry and egg. Photosynthesis. Any other answer for endothermic?
Baking.
Oh yes, baking. It requires energy, right? Baking. What else? But that is enough already. You know, right? As long as they absorb energy, then it is the endothermic reaction. Okay?
Yes.
All right. So now let us continue. So now I want to show you this one. What is this thing called? This is what we call the, as you can see here on the x-axis here is the time. Reaction progress means it is a time. And then this one is the energy, potential energy, or you can just write energy here. This is the energy level diagram. Energy level diagram. So far, so good. Energy level diagram. As you can see here, this is the exothermic reaction. And the one on the right side is endothermic reaction. As mentioned, exothermic reaction, they release energy, right? So before this, they have high energy. When they have released that energy, the energy become lower. So far, so good.
Yes.
Okay, now can you explain to me why this product is higher than the reactant energy level?
Because the energy is being absorbed.
Yes, it's absorbed. All right. So now on your column here, on your second column here, you can draw these two. Or if there's any other graph you can draw. Okay, you can use that one. You can draw that one on your second column. I mean second row. Okay, Oh, I forgot to mention one thing. Jingtong, I would suggest you to draw the energy level diagram with 3 different color pencil, like what is shown here, to show what is activation energy and the energy absorbed or released, to use like 3 different color pencil. I mean pen or anything, 3 different colors. Okay, hello? How long have you not been to swimming pool, my dear? I mean, do you live in a condo or like in a landed house?
Landed house.
Oh, so does your house have swimming pool?
No. Terrace house.
Sorry? Oh, terrace.
Terrace.
I'm living in condo, but I have never been to swimming pool yet.
Wow.
So you see, this is the busy life. Let me know when you are done.
Okay, done.
Okay, so now you know this already. Basically, that is the basic concept of endothermic and exothermic. Okay, now I'm going to show you, this one you know already, blah, 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 blah. Oh, metal and water, you know already, blah, blah, blah. Know already? Yes. Okay, so do you know what is bath foam?
No.
You know, like, never mind. I use another better example. Okay. I'm using this one, the one in your textbook. You see on your textbook page. Okay, is it there? Page 77. 77. Okay, so you see, let's say if we are having sports, someone got injured, we need a cold pack or ice pack to immediately cool the muscle, the injured part down, right? So how do we do that? We do that by having a cold pack. But cold pack is not actually ice, right? How do we make them cold since it is not an ice?
Put ammonium.
So we are going to utilize the endothermic reaction. Like just now, displacement. We know why do we need to have displacement? Endothermic is like it will release the absorb energy, so the temperature decreases, right? So they have this thing here, sodium nitrate. Okay, whenever you squeeze, then it will come into contact with the water, right? So when they dissolve in water, then the reaction will take place. What kind of reaction? Endothermic reaction. They will absorb heat energy, so the whole cold pack will become cooler. As simple as that. Any question?
No.
No, very easy, right? Okay, and now there is also another thing here. Do you see that on your textbook 77? Have you ever tried the Hai Di Lao, the instant hot pot? So you just have to add water, a normal temperature water into the thing, and then it will become hot by itself, right?
Yes.
Have you ever wondered why? Why is that so?
Got a
Yes.
thing to make it.
Got the thing what?
I don't know what is the thing.
Okay, so you go to your page 77. 76 and 77. Can you read the one at the bottom using exothermic reaction?
Which one?
76, the one at the bottom.
Oh, read it out or I read myself?
You read yourself.
Teacher,
Yes.
if later got extra time,
Uh-huh.
explain the unit 8 thing.
Okay.
Okay, thank you.
I'm glad that you brought it up.
Okay. Done.
Okay, so what makes them self-heating cane? Because there's these two items here, calcium oxide and what? Calcium oxide and the water, right? Because you need to add water, so definitely something and water, right? The cold pad also something and water. Okay,
What got calcium oxide and water? The cold
Oh, you
pad?
mean the equation? How does it take place? Okay, so on your textbook there, it is written this one. Let me write it down. So the self-heating can or self-heating instant noodle, instant hot pot, right? It will be calcium oxide react with water. When you add water, it will just become the calcium hydroxide. And this process releases heat energy. That's it. You understand? So we have already done our unit 5. Any question?
No.
No. Okay, so what you want to ask me about the unit 8? Yes, what you want to ask me about the unit 8?
From the collision thing. Then
Sorry?
From the collision thing.
Collision? Oh, the collision thing. Okay. Yes. What you want to ask? Or you're not sure like how does the collision increase or decrease the rate of reaction, right? Okay. The one is unit 8, right? Unit 8.
Just re-explain all the unit 8 thing.
Can. I focus on the collision theory first. The collision theory. Okay. So for collision theory, now, as you can see here, right? In order for collision to take place, they must collide, the particles, they must collide with each other. So for example, let's say, okay, let's say metal to react with oxygen, the easiest one, is going to form metal oxide, right? So the example here is sodium react with oxygen, OO. This is the bond, right? OO. They need to form NaO, right? They will have to form the NaO. NaO, but it is not balanced, right? We need to balance it. There will be 2 NaO. So there will be 2 Na react with one oxygen molecule to form two sodium oxide, right? So this one means, right, the oxygen, they need to break their bond, right? They need to break their bond. Hey, wait, this one is another topic already. Stop recording.